Welcome to Module 3. Module 1 and 2 gave you the discipline and the law. Now we get our hands dirty with the raw material, personal data as it actually exists in production system. By the end of this module, you are going to learn 3 skills. Judging and identifiability, including why anonymized usually isn't. Classifying data so that controls follow risk. And building a data map that can survive contact with reality, including a walked look at how this is done in OneTrust. Final judgment in this whole field is how identifiable is this data? Now let's look at the concept of identified, identifiable, pseudonymized, and anonymized. Now, identified data or identified means you know who the person is. So it could be name, email, account ID, phone number. They are data that you can use to identify a person or identify data subjects. And this is generally in scope of most and all privacy regulations. Now, identifiable means you could single a particular person out. This could be things like device IDs, IP addresses, location traces. Basically, you can easily single out a specific user. Next, which we still have in scope of all privacy laws, is pseudonymized data. Look at pseudonymization as replacing data with tokens, but you still have a key somewhere that you can use to re-identify the data. So legally, this is still personal data, so the full legal obligations still apply, but what you've done is that you've reduced the risk. So look at pseudonymization as a risk reduction measure, but it's not an exit. Now, what we have out of scope of most privacy laws is anonymized data. Anonymized means no one using means and anonymized data are data that no one using reasonable means could re-identify who the data subject are or who or what those personal data are. Now there are lots of tools out there that can help with pseudonymization. Lots of tools out there can help with anonymization. Later in this course, we are going to look at anonymization techniques and some of the trade-off that exist when you anonymize data. Now, nearly everything that I've audited place their data further right on this spectrum than it actually was. Look at personal data and how it actually hides in plain sight. Now, if you ask a product team where their personal data is, they would point at the users table. The users table is actually just the tip. Now, let's look at server logs, for example. They write IPs and session IDs millions of times a day. Location traces, they are devastatingly identifying. Research has shown a handful spatiotemporal points uniquely identifies most people. Analytics and advertising ID exist precisely just to single people out. The next, which is where I actually call it the wildcard, is the free text field, because users can type in anything. Looking at your support tickets, you find users putting in things like health information, financial data. These are all places where we actually don't, where typically teams wouldn't look at to identify data and identify personal data. The next, which I think is one of the most important, is derived data. It could be scores, it could be segments, it could be predictions. It could be predictions about a person, prediction about the personal data that you have created. Now, one other place where most organizations fail to look at is metadata and backups, because this actually contains everything which we've walked throughout the software development life cycle or the product development life cycle to manage. Let's talk about special category data. Article 9 lists these special category data, which could be health data, ethnicity, political opinions, religious or philosophical beliefs, trade union membership, genetic and biometrics data, sex life or sexual orientation data. Now, processing these type of data is prohibited by default. Doesn't mean you can't process them. It just means that you need a special condition on top of your Article 6 basis. Remember we talked about legal and lawful basis. Now you need to have an additional condition on top of that, which is most commonly explicit consent. Now it means a user needs to explicitly consent to allow you to process this type of data before you can process it. Now, here's what I've seen engineers miss. I like to call it the inference trap. You don't actually need to have a column called health data in order for you to hold health data. Look at things like pharmacy purchases, which ties to health data. Look at things like period tracker usage, which also ties to health. Look at things like prayer app activity, which ties to religious or philosophical beliefs. So proxies and inferences, they drag ordinary looking fields, like I've mentioned above, into the Article 9 territory. The engineering advice to this is to identify proxy fields during your classification stage and protect them like the category they reveal. I also forgot to mention criminal offense data. It also falls under special category data, hence should get similar restrictive treatment. Let's talk about pseudonymization and anonymization. This is the two most confused pair in the field. Now, with pseudonymization, data is still re-identifiable. What basically happens is that we swap identifiers with tokens, but the key still exists, so we can easily still get that personal data. So pseudonymized data is still personal data and full obligations apply. However, don't let this sound like a criticism. GDPR explicitly names pseudonymization as a design and security measure, and it's an everyday workhouse, for things like analytics, using test environment, least privilege access, and so on. Anonymization, on the other hand, is a different animal. No party using reasonable means can re-identify that data. Singling out, linkage, inference, all defeated. So anonymized data or anonymization means the data can never be used to identify an individual or a set of individuals. And with pseudonymization, the data can easily be used to re-identify. Now, genuinely achieving anonymization is hard, and it usually costs utility. So if your data is fully anonymized, you find out that it is not very useful, and if it is if the utility is high, you find out that the anonymization is low. Now, when a developer tells you that the data a data is anonymized, important questions that I'll always advise to ask is, what attack is the data anonymized against? Who verified the anonymization? And now, in my own personal audit experience, the honest answer to this question is usually silence. Now, let's talk about why real anonymization is so hard. There are generally three attack patterns. The first one, which is singling out, even with names removed, unique attribute combinations isolate individuals. The classic research finding is that zip code, birth date, and gender alone uniquely identify a large share of population. Next, linkage. Join your anonymous release against voters' roll or social profiles or breach DOMs and identity snapback. This is how famously anonymized movie rating and search data sets were broken. And I'm going to attach a link below this video in the documents section referencing this linkage, the data set, and how the research was actually conducted. Lastly, inference. Deleting the sensitive column doesn't delete the sensitive signal. It can still be predicted from what remains in your data. Now, hold on to this slide. When we reach differential privacy in module 7, you see how to replace hopeful anonymization with mathematical guarantees. Now, let's continue our conversation on classification. Identifiability judgment only pay off when they drive controls. That's actually what classification is. So classify the data in order to be able to apply equivalent controls to that data. A schema that I've seen work is the 4-tier scheme, where tier 0 falls under public and non-personal data, tier 1 falls under internal business data, tier 2 for personal data. In this stage, that's where you need to make sure you have things like minimization in place, purpose tag, retention, jobs, these are coverage, and it's very important to make sure that these things apply automatically. Tier 3 is where you have the special category and high risk data. In this scheme, in this tier, you need to have explicit consent. You need to have strict access, encryption, data protection, impact assessment, audit, login, and so on. So the goal of classifying data as a whole is to be able to apply relevant security controls. Now, two important advice that I'm going to give. Number one, controls must attach to tiers automatically. It's not just about classifying, it's about classifying so that you can apply controls equivalently. Secondly, it's important to resist tier inflation. I've watched 7 tier schemes collapse because nobody could actually remember the difference between tier 2 and tier 3 and tier 4, 5 and tier 6. So it's very important to limit your tiers to 4 or 5. Data mapping. One map, many masters. Everything in privacy engineering eventually routes through one artifact, the data map. Per processing activity, it answers what data, about whom, why, and on what basis, where the data lives, the systems, the vendors, countries, how long the data is kept, and who can touch it. One map serves many masters. Article 30's record of processing activities, which most organizations are legally required to maintain, falls straight out of your data map. Data subject requests depend on it. You cannot export or erase what you cannot locate. So DPIA also starts from your data map. And also, when you have a data breach, the 72 hours clock is start ticking. Your data map is the best place to easily identify what was in the system, who has access, how long is it stored for, what type of data it is. An advice which I would give is, if you are to maintain one privacy artifact very well, make it your data map. Building the data map. How do you actually build the map? Three layer of discovery methods in addition to reconciliation. Number one, interview. It is important to conduct interview and workshops with system or owners so as to quickly understand the data coverage. But it's also important to understand that people mostly describe the system they believe they have. Number two, inspect. Inspecting schema, API contract, codes. This actually tells you what's actually stored and what's actually being transmitted or transferred. Number three, scanning. Automated data discovery, cloud inventories. These are very helpful in catching what nobody mentions. For example, shadow spreadsheets, shadow files, forgotten S3 bucket that has a personal data in it, database from the 2005 migration, and so on. Most importantly, it's important to then reconcile. Every difference between what you were told, what you read, and what you found is a finding. In my own work, the reconciliation step is reliably where the real risk surface. Now, let's move a little bit into the tool and look at OneTrust. OneTrust is actually it is actually the most tool enterprises uses. So if you're to pick out one privacy tool that you must learn, OneTrust is that tool. Again, this is just my personal opinion. I've worked extensively with OneTrust, and the concept in OneTrust generally transfers to any governance tools or any governance platform. Assets, for example, are your registered systems, applications, and vendors with attributes for hosting, for example, location and ownership. Processing activities model each purpose, which are linked to data. data elements, your lawful bases, filter that view, and you are looking at Article 30, record of processing activities. And also data flows visualize movement between assets, flagging cross-boundary transfers that need safeguard. And then most importantly, assessments, which could be DPIA or PIA templates that you can trigger directly from the inventory. You can also build in workflows that automatically chase system owner for updates, chase them on deadlines for completing the assessment. One caution from the trenches: it's very important to understand that privacy tools hold the map, but it doesn't build it. If you feed it lazy discovery, you get a beautifully formatted fiction. The uncomfortable truth about data maps is that they are only true the day you finish them. Systems change weekly and even daily with the surge of generative AI. So a map maintained on an annual basis is just a historical document. The fix to this is wiring updates into processes that change systems. For example, when a new feature or field is being added, the design review should include a map delta, so as to understand what type of data is being added, what is the purpose, what tier does it fall under, what is the applicable retention period. Also, when adding a new vendor or SDK, putting processes in place to make sure that procurement doesn't sign until the asset is registered. This gate is helpful as um, um, it helps act as a teeth to make sure it grabs assets before they actually get used in production. Also, architectural changes should update flows before going live, not after. And most importantly, quarterly automated rescan on the different systems that you hold is helpful in verifying and also finding what your maps may have missed. This becomes your Article 25 applied to your own governance, where we've talked about privacy by design, not just conducting these checks on an annual basis or only whenever you're about to get audited. Four key takeaways from this module that I want all listeners to carry forward. Number one, identifiability is a spectrum. Personalized data also carries full obligations. And also, most importantly, every anonymization claim deserves the question against which attacks. It is important to understand what attacks that data has been anonymized against. Number two, personal data hides frequently far beyond the user's table. Personal data hides in logs, in free text fields, inferences, backups, and so on. Number three, proxies can make ordinary fields become special category. It's important to classify by what the data reveals, not just by the column names. Number 4, the data map is the keystone. Right fulfillments, row pass, DPIAs, breach response all stands on your data map. So its upkeep must be wired into your change processes. Now, next module is where it gets genuinely fun. I hope so. We're going to talk about threat modeling using Lindon. Taking everything we now know about the data and systematically hunting for the ways it can hurt people. See you in module 4.